We move to Dr. Peter Jacklyn, who, again, you need no introduction to because he's been part of our discussions today and other presentations on NRV system.
Yes, thanks, Jeremy. Yeah, thanks everybody, and hello to all our international guests today. I manage the North Australia and Rangelands Information Service, or NAFI, which functions as an MRV, which I'll explain in a minute. So, first of all, what is exactly an MRV? It stands for Monitoring, Reporting and Verification. So, first of all, it aims to monitor and measure the emission reduction or removal associated with a carbon activity. And it then reports on these reductions and it verifies that the reductions are accurate. So it should do this in a transparent way so that the reductions are trusted by stakeholders in the activity or the market, and in that way supporting the integrity of the methodology. Now, this is just one way that the methodology integrity is supported. As Anna mentioned, there are others, the basic additionality of the system, as she mentioned. So, but this is an important way also of supporting the integrity, and it is a way in which your integrity can also be damaged if your MRV system isn't very good. And one way it can do that is, and integrity is important for a couple of reasons. One is if your perceived integrity of the methodology goes down, it can impact on the price of your credits. That impacts on all of your projects. It can also, if you've got an integrity that is under question, it can also impact on the amount of participants that are entering into your method. So there's a lot of negatives if you don't place integrity as a very important thing to maintain. And one of the best ways to, I guess, ensure that this occurs is by following some of these guidelines that are in the Paris Agreement. It's Article 6 of the Paris Agreement, and that lists a set of criteria that are considered important for an MRV. The first one is it should be accurate. If you're going to measure emission reductions or carbon removals, you want to make sure that that's suitably accurate for your activity. It should also be complete. In other words, you want to measure all your sources of emission. One of the relevant areas there for savanna burning is you want to measure all the areas of your methodology zone, anywhere that a project could be placed. You want to make sure you're accurately measuring the emissions from all of that methodology zone, which in Australia is a pretty big area. It should be transparent. This is pretty important. People should be able to access the data on your emissions. They should be able to have a look at how the thing is going, and it should be explainable as well. You should be able to explain how your methods work to people. The other thing it should be is consistent. These projects will go for 25 years quite often. During that time, you'll be using various sorts of technology that'll probably change over that period. You want to make sure that when you change your technology, suddenly all your measurements don't suddenly go up or down. They should only be affected by the activity itself. And it should also be conservative. You should, if anything, perhaps slightly underestimate the reductions that the projects are making. You don't want to overestimate. You don't want to risk people being seen to be sort of laughing all the way to the bank, as it were, not having done the work, because that can affect your reputation as well. So how did we try and achieve this in the Australian savanna burning context? How did we go about our MRV? Well, I guess the interesting thing there is that our MRV was started before the carbon projects started. It wasn't started as a tool for monitoring, reporting and verification. It was it emerged as a tool just to help people manage fire. Quite a few years before the carbon project started. It came out of a cooperative research centre, we call them here in Australia. It was to help people manage savanna landscapes here. It brought together, and this is a project that Jeremy led, brought together a whole series of people, the land managers, the fire managers, traditional owners, it included Indigenous rangers, pastoralists, park rangers. It brought them all together across the savannahs, together with technical specialists and scientists, to try and work out ways to help them improve the way they manage their country with fire. Fire was a big threat. And what happened then was that they realised that they needed a tool to help them monitor fire. And they approached us, we were with the CRC at the time, and they said, can you get us, using this new technology of satellite, new satellites they were aware of, can you get us a website that'll help us monitor these fires? So it wasn't even our idea. And so we said, sure, we can do that. And that's how it started. And we, first of all, got the satellite data. We used these polar orbiting satellites to measure the fire. That process is completely automated. That's what those little cogs mean, completely automated process, and a completely automated algorithms that generate the locations of fire, upper spots, for example. That then gave us an image. We then worked out how to automatically map fires from that image using reasonably simple artificial intelligence. Then here's one of the key steps. That wasn't accurate enough. We got then mappers to edit that automated mapping to ensure that it was accurate. And this was a very strong message from the fire managers. They needed these fire scar maps of burn areas to be as accurate as possible. If you want to see if that road has pulled up that fire, you want to know exactly where that fire scar is. Is it on one side of the road or the other? Has that road been effective? Is there a gap in those fire scars that'll form a good barrier? So accuracy was a key criteria. That's why we use these mappers with knowledge of country to bring that accuracy up to the level that people need. And we displayed every time there was a regular overpass, we displayed these maps of fire scars and hotspots as regularly as possible, because these fires are moving across the landscape, people need to respond to them. And we put it on a website. And that's, and people, you know, although a lot of them are private property owners, they need to know what their neighbours were doing. If you're a government agency, you might want to know what the whole region is doing, what the fire activity is over the whole region. So we put it on a publicly available website, because the people who are managing fire in North Australia are not just people in agencies in government. They're people out on country, rangers, pastoralists, park rangers. So everybody needed to know what these fires were doing. And finally, we did a final check at the end of the year, picked up anything you might have missed to bring the fire history up to as being as accurate as we could. And that was going well before the carbon projects came along. But when the carbon projects did come along, we realised that we'd already hit a lot of these criteria already. We'd already got an accurate MRV. It was complete across the savannahs, because as I said, some of these agencies need to know accurate fire scars across the whole of their jurisdiction. It was transparent, it was on a public website, and it was, we'd established a model so that we could be consistent. And that's because, like an MRV, fire managers need to know what's going on in the real world, and they need to trust that you're giving a picture of what's going on in the real world. What we didn't yet really have was some of the things that an MRV in particular needs. And that is, and I've put up conservative there, that's this issue where what an MRV is particularly sensitive to is significant error. You don't want to make a significant error in your MRV, in your fire scar mapping, let's say. If it was just fire managers, and let's say there was a glitch and you missed out a whole bunch of properties somewhere, you didn't map any fire for them for some reason, they would be pretty cranky if they were fire managers. They'd probably complain, they might get onto you, might map it eventually. But if you did that in an MRV that was, and they were carbon projects, well, they might be saying, oh, great, you know, I've got 0 emissions this year, don't tell anybody. And cashing their checks. But if that gets out, that'll get out there, and that could become a media story. The media like bashing offset projects at the moment. That could then result in a drop in the reputation of your Savannah burning method. You could lose 10% off your credit price. That's in the industry today, that's $7 million. So in other words, we now validate regular validation and a lot more checking. And it then goes to the third party verifier. And that's what you might have heard, SAVBAT. And so those accurate fire scars go into SAVBAT. Just finally, so we've ended up with an MRV system that is not just an MRV that reports to the independent verifier. It is also an MRV that is used regularly by all of the fire managers across the Savannahs. And that has a number of benefits. So it builds that trust because they're using the fire scar data that goes into the MRV every day, like an everyday tool. The engagement also allows you to build capacity. This shows a workshop we had earlier today. You know, we've had two of these rooms today, and so because they're familiar with the data from the MRV, you can help them increase that engagement and educate them and build their capacity and help them do their own, run their own projects better, because they've already got this level of engagement. And finally, you can also help build understanding in the broader community because you have all this data at your fingertips now that's publicly available. So that's it. Okay. Any questions? Yeah. I'm sorry.
I have one. So with regards to the automated fire detection, are you using, do you know which satellites you're using? Because I gather that the Modus Earth fire burning product is currently on its way out. So I was just wondering which satellites you're using for the automated fire detection.
Yes, that's right. So at the moment, we're using a range of satellites for if you say automated fire detection, I guess the important thing for the MRV is the burnt area mapping, the fire scar mapping. We use a mix of the Sentinel-2 satellite and the moderate resolution satellites. Yeah, so we realise this is a big topic for us, the imminent demise of Modus. So we do use Modus satellites. Terra is quite good because it passes overhead in the morning. It's rather clear images. But we have been aware of this issue for a number of years now. So we're able to use the VERS satellites. There's a number of those now. We're also using Sentinel-3, which is a morning satellite, a bit higher resolution than the VERS. So yeah, we've got a lot of backup once Terra goes. But Terra is very important for hotspots, and that is a live issue for us. And it's not as easily replaceable for hotspots. That
was going to be my next question. So,
no, it's an issue. It's important for getting that first 10 a.m. look, 10:30 a.m., 11 a.m. look at a fire. And if Terra goes, we've got a bit of an issue on our hands. We've already put a submission into the NASA workshop. They're going to have a review later this year. And all you guys are going to be affected by this because you're all going to be wanting probably to monitor your hotspots, which is the way people check their fires. So, yeah, look, just approach me if you also want to make a submission to NASA because this will affect everybody. And we're hoping that this senior review later in the year will decide to extend Terra's lifetime for another 3 or 4 years. The obvious substitute is the Fen-Yung 3F satellite that's being launched next Tuesday. But that's Chinese, and that comes with its own issues, which I won't go into.
Hi. So a working MRV system is mandatory to have the carbon market working. And when you're talking about like the countries that we're representing mostly, we don't really have that working, or at least automated. Do you have that word? Sorry. So it doesn't work automatically in a way that it can, you know, monitor your landscape or the whole country. So that's the case for Brazil. Sorry to ask, but how long it took so you would have this working system, and how much did it cost? Because that's usually a big problem, even in projects. Like when you get donors, you won't have that kind of money. Like it's a huge amount, and it's a long-term thing. So how did you manage, or how long did it take so you would really make this work in the market?
Yes. So, and I guess it did take a long time. As I mentioned, we developed this system out of a cooperative research centre, which had done a lot of background work. We probably started thinking about this in the early 2000s, 2002. The first carbon project, we launched the system in 2003. The first carbon projects didn't really come along until around the mid of 2005, 2006. And as I mentioned, by that time, we already had the system in place. It didn't cost a lot in the early days. It was a little computer under my desk in the early days, but it now costs around $750,000 a year. But it is a very large area, and it's the sort of thing you can grow, and that's what we did. But look, we did do it over quite some time. So look, I can't tell you we developed it quickly, but we you know. There's a lot of, it should be easier now because a lot of lessons have been learned. And also the, I mean, the expensive part is the mappers, the people who sit there and edit the mapping. That's the bulk of a lot of our costs. But they have a lot of benefits beyond just the mapping. You don't want to have somebody mapping 20 full time because you sort of go mad. So they're all sort of part-time mappers, but the rest of the time they're really valuable in engaging with users and doing all these other jobs for us. So we find it well worth the investment. But no, it's not cheap, and we did take some time to develop it.